Hello, salam alaikum. Greetings to you. I'm here to solve exercise 6 problems. So in this video, we are going to solve these problems in exercise 6. Okay, let us start with number 1. Please, as you are watching this video, share it with some of the friends about our channel, and this is going to be a great thing for us. Okay, let us start with number 1. Number 1 is saying, let Z1 is equal to 3i, Z2 is equal to 2 minus 2i. Now you are being told to find magnitude of Z1 plus Z2. So when you look at this thing here, this parallel line, just something like of this kind. So this one is meaning magnitude. If I write it in this way, so it means the magnitude of a complex number Z. That one means magnitude. You don't need to worry about it. This one is the magnitude, or what we call the modulus of a complex number. Modulus of a complex number. So next time, no words again. Okay, for us now to solve this, to find the modulus of Z1 plus Z2. Z1, modulus of Z1 plus Z2. So what we have to do, we need to first add Z1 with Z2. Then after adding the two complex numbers Z1 and Z2, then now we shall find the modulus of the both. So this is unknown. So we have to find the addition of Z1 and Z2. So Z1 here is given as 3i. So that means the real part or real number is 0. So we have Z1 which is 3i. So this one is 3i. So plus a second complex number Z2 which is this one here. 2 minus 2i. So what we have to do is to open the brackets. To open the bracket here. Then we collect the like terms. Just like the addition of complex numbers. So this is going to be 3i plus 2 minus 2i. Here you have to collect like terms. 3i and 2i are like terms. So you have to now say that 3i minus 2i plus 2. So this is going to be 3i minus 2i is going to give you I. So therefore you will have 2 plus I. So bring 2 first because it is a real number. So this is the addition of these two complex numbers. But the question here is telling you to find the magnitude of Z1 plus Z2. So see, now you have arrived to this one, you have to get the modulus or magnitude. So how do we get the magnitude? So before we said that magnitude, which is represented by R, is equal to root of A square plus B square, where A is the real number and B is imaginary number. So now we have to substitute the value of real number and the value of imaginary number. So you will have R, which is magnitude. Now you can write this one as magnitude of Z1 plus Z2 is equal to what? Is equal to square root of A, which is 2. 2 square. Then the value of B here is 1. You have to take the coefficient of I. No, this is 1 square. So therefore this is equal to square root of 2 square is 4 plus 1 square, which is 5. So answer is square root of 5 units. Square root of 5 units. So this is the magnitude of Z1 plus Z2. So that is how you can find or compute magnitude or modulus of Z1 plus Z2. So let's come to this one here. Z1 minus Z2. So here you are looking for the magnitude of or modulus of Z1 minus Z2. So what you have to do, you need to subtract the two complex numbers, z1 which is equal to 3i, so is equal to 3i minus z2 which is 2 minus 2i. So here you have to open the bracket. This is going to give you 3i. Negative and positive here will give you negative 2. Then multiply this negative by this negative to give you positive. So here you will have positive 2i. Now collect like terms. Collect like terms. You will have negative 2, then plus 3i plus 2i. This is going to give you negative 2, then 3i plus 2i, you will get 5i. So this is the result of subtracting the two complex numbers z1 and z2. But what you are looking for is the what? You are looking for a modulus of z1 minus z2. So this is z1 minus z2. So since you have arrived to this, so you have to now find the modulus. So from the formula where modulus is equal, which is represented by r, is equal to the square root of a square plus b square. This is the modulus. So therefore, modulus of z1 minus z2 is equal to square root of a square. A square is negative 2. So substitute negative 2 square. Put it inside in the bracket with a negative. Plus the square of b. B here is 5. B is 5 in this one here. So 5 is square. So now when you get the square root of negative 2 square is 4. Then plus 5 square. 5 square is 25. 25 plus 4 is 29. So this is your modulus for this complex number z1 minus z2. Answer is equal to square root of 29 units. Square root of 29 units. So that is it. Okay, now we are done with the A. So let us come to B. So B is saying express Z1 and Z2 in polar form. So in this case, you have to first take Z1 and then express that Z1 in polar form. Then after expressing Z1 in polar form, go to Z2 and express it in polar form. So we have Z1 is equal to 3i. So this means that the real part is 0. That's why it is not included there. Is it right? What did we say about writing a number in polar form? So we say we need to first find the modulus. We need to first find the modulus or magnitude of a complex number. After getting the magnitude of complex number, we then find the angle of a complex number. Then we write it in polar form. If that one is clear, it is going to be very easy for us to solve this. Okay, let's say solution. So we are going to start with the modulus, which is represented by r. R is equal to square root of a square plus b square, is it? So therefore our r is going to be equal to z1, which is 3i. So this means that a here is 0. We know real part is 0, that's why it is not there. Then plus imaginary part, we have 3 as imaginary number. This is going to be 3 square. So this is equal to square root of 9. 3 square is 9. So therefore r is equal to 3 units. So this is the modulus. Now you have the modulus. So let us come here to get the argument or angle of this complex number. So how do we get theta before? We used to get theta by saying theta is equal to tan inverse of b out of a. So this was the formula for getting it. Tan inverse is equal to tan inverse of b, the imaginary number here is 3. So it is b which is 3 divided by 0. So when you look at this one, you will have 0. So for this one here, tan inverse of 0 is 0. When a complex number is giving you this one here, like 0, so what you have to do, you need to find this complex number. You have to draw this complex number and see is it in which quadrant. So to draw this one here, it is just like this. On real number here is what is 0, so it is not located on real number. So this one is purely imaginary number, purely imaginary. So it is located somewhere here, like 3i. So this is the angle. This is the angle of the complex number. The angle here is angle of 90 degrees, you see. So you can say theta is equal to 90 here. Theta is equal to 90. So now you have theta which is equal to 90 and r which is 3 units. So you can now get your you can write this complex number in polar form, where z1 is equal to r. So a polar form of complex number is z is equal to r outside bracket cos of theta plus I sine theta. So this is the polar form of complex number. Therefore, to express z1 in polar form, z1 is equal to r, which is 3 outside bracket cos theta, which is 90, cos theta, which is 90 degrees, plus I sine 90 degrees. So, and therefore, this is the final answer for z1 in polar form. Z1 is equal to 3 outside bracket cos 90 degrees plus I sine 90 degrees. So the first step is getting r, which is this, and then you find the angle or argument. So in this scenario where this one becomes tan 0, this become out of 0, where one part is 0, where one part of complex number is 0, you need to draw the complex number. You draw the complex number and then you plot it on the diagram and see is it in which quadrant. Like this one here now is in the first quadrant, which is angle of 90. So that is it. Let's go to Z2. So let's express Z2 in polar form. So to express Z2 in polar form, and we know Z2 is equal to 2 is equal to 2 minus 2i. Okay, so what we have to deal with first is the modulus r. So r of this complex number z2 is equal to a square plus b square, and a is the real number, which is 2 there, so it is going to be 2 square plus negative 2 square. Negative 2 represents b, so the complex number is going to be equal to square of 2 is 4, square of negative 2 is the same as 4. This is going to be root of 8. So root of 8 is the same as 4 times 2. So this is going to be 2 root of 2. 2 root of 2 units. So the modulus is going to be 2 root of 2, modulus of z2. Now let us come to theta, or the angle of z2. So we know angle is equal to tan inverse. It's the same as tan inverse of b out of a. So here we will have our tan inverse of b, which is negative 2, negative 2 divided by a, which is 2. So this is going to be tan inverse of 1. tan inverse of negative 1 of negative 1. So what is the tan inverse of negative 1? It is the same as negative 45. It is the same as negative 45. You press calculator and you'll get tan inverse of negative 1 is 45, negative 45. Since you have the 2, you have r, which is 2 root of 2, and theta is negative 45. You can now express the 2 in polar form. You can say the polar form of a complex number is equal to r cos theta plus I sin theta. So therefore Z2 is equal to r, which is 2 root of 2 times cos of angle, which is negative 45 degrees, plus I sin negative 45. Negative 45 degrees. So this is the polar form of Z2. That is the polar form of Z2.